All right, today's lesson sounds a little intimidating, but hopefully you'll find it maybe a little bit easier than what you've done before. You might have learned a little bit of this in Algebra 1. Some of you may have not learned it, but it's called trigonometry. Trigonometry. Now, what's this whole chapter been about? Chapter 8. Not just triangles, okay, right triangles, right triangles. So trigonometry, or trig, all right, instead of saying trigonometry all the time, we can just shorten it, say trig, sounds kind of cool, all right, is basically, it's the study of right triangles, okay, it's finding right triangles. But we've talked about finding the lengths of sides on a 45, 45, and a 30, 60, 90 triangle. But those are special triangles. What if we had a triangle that was not 45, 45, 90, that was not 30, 60, 90? Okay, but, oops, let's go. I don't know, we'll just make up some crazy angle right here. Let's say this was 27 degrees. If this was 27 degrees right here, and I knew the length of this side right there, right now, there's no way that you could find those other sides. I can't use Pythagorean theorem. Why not? Because I don't know another side. I need two sides, right, to do Pythagorean theorem. All right, so trigonometry, if I have this as a 27-degree angle, and I know this side right here, there's no way that I could solve for any of these. Let's just call this y. Oops, it's not very good. Y. We'll call this y, and we'll call this h for a hypotenuse. There's no way that we could solve this right now, okay? You don't have the tools right now to figure this out. So that's what we're going to learn today, okay? So hopefully by the end of class, we'll be able to solve for these two sides. Now, you could find this angle right here, though, couldn't you? How could you find this angle right here? Yeah, just take this away from 90, and that would be, what? That's 63 degrees, right? So you could find that angle, but that's it. You couldn't find the other two sides. So what we're going to do today is learn some techniques to be able to solve for the other missing sides. All right? So let's start off with another right triangle, and let's label it a little bit. Yeah, it's over. I'm done. I'm not telling the story. Okay, so let's do this. Let's call this angle right here. Let's just let's put an A out here, and we'll call this angle A, and we'll call this B, and we'll call this C. All right. So we'll call this A, B, and C. Now, what I want to do is I'm just talking about this angle A right here. Okay, I'm only looking at this angle A. What would this side right here, AC or CA, be called? It's a right triangle, so it would be called the what? What's the name? What's the word? It's the hypotenuse, right? We've talked about that before, but let's just write it in there. So that would be the hypotenuse. Now, here's the part that you really need to watch. Look at this side right here, this side CB. What is CB in relationship to angle A? It's across from it, right? But we don't say across from it, but that's a good way to talk about it. We say it's what? We've used this word before. It's what? It's not adjacent to it. It's opposite. It's opposite this angle. We've talked about that kind of stuff before, haven't we? We said, remember we had two equal sides, and we had a, let's say you had a isosceles triangle, two equal sides. We talked about the angles opposite the equal sides. So we have discussed that before. So that's nothing brand new to us. But we're going to call this the opposite side. Now, it all depends what angle we're talking about, though, doesn't it? Okay, this side right here is not opposite angle C, though, is it? All right, but if we're talking about angle A, and I've got it marked right here, this side is opposite angle A. Does that make sense? What would this side, you guys already said that word once, but what would this side be to angle A? This would be adjacent. All right, it's adjacent to angle A. Is it adjacent to angle C? No, it's not, but it is adjacent to angle A. Now, some people, I don't know if you thought about this yet or not, but some people say, well, what about the hypotenuse? The hypotenuse is also adjacent to angle A, isn't it? All right, but we don't call the hypotenuse the adjacent side. All right, we call this the hypotenuse. That kind of supersedes everything, right? That's like more important on the hierarchy of sides of a right triangle. So we always call this one the hypotenuse. How do you know it's the hypotenuse? Because it's what? It's across from, or it's opposite the what? The right angle. Okay, so that's always going to be the hypotenuse. But if I'm talking about angle A, this would be the adjacent side. If I'm talking about angle A, this would be the opposite side. What if I wasn't talking about angle A? What if I was talking about angle C? then what would this side be called? This would be opposite angle C, wouldn't it? What would this side be in relationship to angle C? It'd be adjacent. So it all depends which angle we're dealing with. Would you agree? All right. Now, what we had a whole section on ratios, didn't we? We did a whole chapter on ratios. So we're going to do a couple more ratios. There's 3 words, 3 crazy words that deal with ratios, okay? The first word is I tell you what, let's do this one first. Let's do the sine. S-I-N-E, okay? So I'm not really sure where these words come from. I should look it up one day. Who knows where they come from, but it doesn't really matter right now. But the sine the word sine represents a ratio between 2 sides of a right triangle. Well, which 2 sides? I got 3 sides, right? I could compare the opposite and the adjacent. I can compare the adjacent and the hypotenuse. I could compare the opposite and the hypotenuse, right? I could make several different comparisons. But which comparison is the sine? Well, somebody a long time ago said that the sine of this particular angle is this ratio. Okay, it's the opposite over the hypotenuse. And I'm just going to shorten these words so I don't have to write the whole thing out. Everybody with me on this? So the sine of an angle represents a ratio. It's a comparison. I'm comparing the opposite side to the hypotenuse. I'm going to make a little fraction out of it. And the word sine just means it's the ratio between the opposite side and the hypotenuse. Now that'd be kind of dumb to say every single time. Say, okay, the ratio of the opposite side to the hypotenuse. Instead of saying that every single time, we can just shorten it and say what? The sine of the angle. So when I say the sine of the angle, the sine of angle A, you know to do what? You know to take the ratio of the opposite side to the hypotenuse, or compare the opposite side to the hypotenuse. Okay? That's what that word sine means. There's another word. Let's do cosine. All right? C-O-S-I-N-E. Cosine. That's another ratio. And it also has to deal with the hypotenuse. So it's not the opposite over the hypotenuse. What do you think it is? It's the adjacent over the hypotenuse. Now, who came up with these things? I really don't know. I don't know who came up with these. I don't know if anybody knows. Maybe it happened so long ago. The history of it just got, messed up. I don't think it's associated with one particular person. But anyway. You could look it up if you want. You got the internet right at your fingertips. So the cosine is the adjacent. So instead of saying this, okay, take a look at angle A, and let's take the ratio of the adjacent side to the hypotenuse. Okay, that would be a lot of words. Okay, it'd be too much. So what do we use? We use this word cosine, and that represents the adjacent side divided by the hypotenuse. And you're going to see how this all comes together in a little bit. But bear with me right now, okay? We have one more word, and it's called the tangent. Right. So the tangent. Let's see what the tangent is. What other ratios can we have? Well, we've already dealt with the opposite and the hypotenuse, the adjacent and the hypotenuse. What 2 are left? The opposite and the adjacent ones, right? And for some reason, they put the tangent as the opposite over the adjacent, not the adjacent over opposite. Now, that the adjacent over the opposite is something else. It's called the cotangent, but we're not going to worry about that. There are inverses of these. Like if I flip this around and did the hypotenuse to the opposite, we'd call that the cosecant. If I do the hypotenuse over the adjacent, that would be the secant. Don't worry about those. That would be an Algebra 2 topic, okay? We're not going to hit that at all in geometry, all right? So don't worry about that. Just worry about these 3. Shouldn't say worry. Don't worry about them. I mean, you don't need to worry, but you should be concerned. You should know them. All right, this is really important right there. Now, that would be kind of hard to memorize, sitting there, okay, the sine is the opposite over the hypotenuse. You're just sitting there saying it over to your, again, like 1,500 times just to remember it. Well, we have a nice little way to remember this, okay? It's not a real word, but it sounds kind of cool, and this is what we do. Instead of saying the sine is the opposite over the hypotenuse, watch, let's write it like this. You understand that? S is O over H. And instead of cosine, we'll put a C, and this is the adjacent over the hypotenuse. And instead of tangent, we're going to say it's the opposite over the adjacent. All right, that's a little shorter, a little nicer to look at, but there's even a better way to write this. Watch. We're going to write this, just so I can remember which one is the sine. Okay, which ratio between what two sides is the sine, the cosine, and the tangent? So we'll write this, SOH. We'll pronounce that so, SOH. And this would be what? C what? Sohcahtoa? So, ka, and then what would this one be? Toa. We'll call it Toa, all right? So we call it Sohcahtoa. Or if you want to put it all together, Sohcahtoa. All right? That right there is your little device, your little mnemonic device to remember what these relationships are. And that's very, very, very helpful, okay? Memorize this, and then that'll help you understand what these things are. Okay, you probably heard it before, okay? I told one of my classes, go in the hallway when you see each other, say Sohcahtoa, right? And then people are looking at you like you're some weirdo or something. I don't think they ever did. And that was the honors class. You'd figure they would be geeky enough to do that, you know. But do that sometime. Tell somebody Sohcahtoa, or tell somebody in a upper level class, like in a pre-calc or even algebra 2 and pre-calc and stuff like that. Say Sohcahtoa, and they'll know exactly what you're talking about. Okay, Sohcahtoa. Again, let's break it down. What does it mean? It means I tell you what. Let's put this right there. What does this mean? The so part of it. The sine is what? Talk to me. Right, is the opposite over the hypotenuse. What's this one? The C represents cosine is what? Adjacent over the hypotenuse. And what's this one? Tangent, opposite over adjacent. Okay? So, remember it. Sohcahtoa. It sounds like a Native American word or something like that. Can you imagine somebody walking around Sohcahtoa? Or like maybe a Japanese word like Sohcahtoa, or something like that. It sounds cool. Sohcahtoa. Now, when I was, I'll give a little props to my math teacher. When I was in high school, we said Toa Soka. We said Toa Soka, but I've never heard any other teacher say Toa Soka, and that's how I memorized it all through high school and college, and even into my many years of teaching. I always remembered it Toa Soka. I don't know, it just seems kind of to flow a little bit, but most teachers say Sohcahtoa, so I converted to Sohcahtoa because a lot of other teachers say it, and then it doesn't confuse the students. All right, so you say, how in the world is that going to help you do this? Let's do it a little bit before we actually start doing some examples here. All right. Yeah. Yeah. It's almost there. So we'll start doing the examples after the 15 minutes. Okay. What if you had this? We'll call this angle A, and I'll just call this A, B, and C like we did before. And let's put some numbers in here. Let's say that's 5. Let's say that's 9. Let's say that's 12. Okay, we'll say it's 12. All right, it's not a special triangle or anything like that. It's not a Pythagorean triple. It's just some numbers. All right. Is it a triangle though? Take the two shorter ones. The two shorter ones have to be longer than the third one. Yes, it works. So that is a triangle. What if I asked you to do this? What if I asked you to find the sine of angle A? This is how we do it. Oh, I didn't shorthand it. Well, I did a little bit. No, I didn't at all. Okay, instead of writing that word sine out, we just use the first 3 letters. We use S-I-N. I know it looks like the word sin, but we don't say sin, we say sine. All right, so we say sine. Instead of cosine, what do you think? 3 letters. C-O-S. All right, so we call it the cosine even though it's C-O-S. Then the tangent, of course, is T-A-N. All right, so those are the abbreviations we're going to use instead of writing out the whole entire word. All right, so we've got the sine of angle A, and I want to find the cosine of angle A. We should be able to do this in a minute, and then I'll switch to the other video. So what's the sine of angle A? Here's the angle. The sine is what? So, S-O-H. What is that? It's opposite over what? Hypotenuse. So which side is opposite here? Angle A. 5 over what? 12. Good. What about the cosine? The cosine is Sohcah, C-A-H. What is it? It's adjacent over hypotenuse, which is 9 over 12. Almost done. The tangent is opposite over adjacent, which is 5 over 9. So that's how we set these things up, okay? And you say, well, big deal. Well, it is a big deal because we're actually going to be able to find that angle knowing that information right there. We'll do that in the next video.